Guys, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In today's discussion, we're going to look at the concept of Pythagorean theorem and the distance formula. And this is going to be a follow-up video on the first one that we had done on the introductory part of geometry, whereby we had looked at different aspects of a point, segment, and length. And we had said that basically we can be able to describe a point as an infinitesimally small location in space, which is going to lack these three aspects of length, width, and height. Now, in this specific discussion, we're going to see that the aspect of distance is going to exploit this particular concept of length. And in our last discussion, apart from the point, we had talked about the concept of a line segment. And of course, this is going to assist us in trying to describe this specific concept of length. Now, in that particular case also, we talked about the concept of length of this specific segment. And we had given a specific formula, of course, which we're going to see later being applied in this specific concept of Pythagorean theorem. Now, in this specific case, I decided that we can be able to denote a point in space using that specific dot. And of course, I can see that that is point P being given as such. And we see that for a line segment, this is going to be the distance between two endpoints, which we can be able to give as a PQ. And we say that the denotation for this specific aspect of a line segment can be given as such using a PQ. And the length, of course, we can be able to describe this aspect of a length using this PQ given as such. And of course, we can be able to see the difference between the line segment, description for the line segment and the length using the two. Now, in today's illustration, we're going to see that we can be able to evaluate a length using this particular concept of a Pythagorean theorem. And that is going to be one of the major objectives of this specific discussion. Now, having said that, we said that we can be able to give the description of a segment PQ using these two endpoints for P and Q respectively. Now, if this specific segment that we have given, which is denoted as PQ, is extended infinitely in both directions, and then therefore we are going to have this one being given. So let me just use another example. So you can have PQ being given as such, and it is extending both to the right and left infinitely in those specific directions. Then therefore we're going to have what we're going to describe as a line. So therefore we can be able to define a line as a set of points which are going to extend infinitely in the right and left direction, or in both directions. And of course, they are going to have this characteristic of length that I talked about, but they are going to lack what we refer to as the width and the height. So basically, these are going to be one of the characteristics of a line is that it lacks the width and the height, but it's going to consist of a length, which I've said is going to go infinitely in both directions of this line segment PQ. So therefore, we are going to describe this particular concept of a line. And in some of our videos, we have talked about the equation of a straight line, and we defined a straight line as the shortest distance between those two specific points under consideration for our case. Then therefore, it's going to be the shortest distance between P and Q, and it's going to extend in that specific direction. Now, this is going to assist us and develop what we refer to as a number line, which is going to consist of a various range of points which are going to lie along this straight line that we're going to refer to as a number line. And that is going to be a description of the points from a point of origin or towards the right and left, as I've indicated for this characteristic of a line. So therefore, this is going to be extending in the negative direction for the left, and then it's going to be extending in the positive direction for the right, given as such. So in this particular case, then therefore we can, just as we are given the length of a segment as PQ, we can be able to describe the length of a line using those specific points. And these points, in a sense, then therefore we are going to match them with what we refer to as a coordinate system. We said that a coordinate system is going to assist us try to quantify some aspect of vectors, of course, or to quantify some aspect of vectors, since we said that vectors have magnitude and direction. So therefore, for us to describe the concept of a magnitude of this line segment, or this line and the segment, and then therefore we can be able to use that concept of a coordinate system. therefore, in this particular case, then therefore that is going to require us to use the concept of Pythagorean theorem. And of course, I'm going to use an illustration, just a simple illustration on the board, to assist us try to, of course, figure out how that one can be done. Now, suppose I have a line segment which is going to be A from endpoints AP, and this AP is a straight line, and I can be able to identify the particular locations in this particular space of a coordinate system. This is a two-dimension coordinate system for x, y. I can be able to identify the coordinates for those specific points. Now, suppose this is we say that we can be able to indicate the coordinates as x1, y1, and this is perhaps x0, y0 given as such. So in any case, if we had specific coordinates in numerical form for this particular coordinates for x0, y0, x1, y1, let me just give an hypothetical example, that is 3 and 2. And then the last one, we're going to have it given as perhaps 9. This is 9. And then we have 4. So those are respective coordinates for x and y. Therefore, we can be able to find the distance between A, B by trying to find the magnitude of A out of B minus A given as such. So this is going to imply magnitude, implying that we are going to find the distance between the two by finding the difference between those respective points, whereby we're going to have this one given in terms of a right triangle. So therefore, this is just going to give us. So this is going to be the change in y or the change in x given as such. So those are going to give us the difference between those specific lines. So the change in y is going to be 4 minus 2 in that specific case. So it's going to be the magnitude of 4 minus 2, which is going to be given as 2. And then the difference in the x-axis is going to be the difference between the x1 and the x0, which is going to be 9 minus 3. Therefore, it's going to be the magnitude between 9 and 3, and this is going to be 6, given as such. So therefore, we can be able to describe the length of this AB using those two specific differences, whereby we're going to see that for us to find AB, we're going to use Pythagoras theorem, whereby the square of AB is going to be the sum of the square of the difference in the y plus the sum of the square of the difference in x. So these are going to be squares given as such. So we can be able to find that one, the square of AB, by finding it. So the distance AB squared is going to be the same as the difference in this one is going to be the square of 2. Plus the distance in x is going to be the square of 6, which is going to be, just to do an evaluation of this, this is 4 plus, this is 36, and this is going to be the, so therefore I can just use this space. So I'm going to have the square of AB given as 40. So the absolute value for this one, therefore, is going to be a positive value, which is going to be the square of 4 times 10, and this is going to be, of course, using the laws of radicals, and of course that's, we are going to find this one given as 2 the root of 10 in terms of length, maybe in centimeters. This is going to be a length in terms of a unit. So therefore we can be able to describe this specific distance using this particular concept, and this is going to entail what we refer to as Pythagorean theorem. So therefore the square of the distance between AB is equivalent to the square of the distance between the x-axis and the y-axis. Therefore, it's going to constitute what we refer to as Pythagorean theorem. So this concept is going to assist us evaluate several aspects of our distance, especially when we're talking about these specific vectors in a 3-dimension or a 2-dimension coordinate system. And of course, this is going to be heavily applied in various aspects of geometry that we're going to see. So in this specific topic, I presume that we have understood the concept of a Pythagorean theorem and how we can be able to find the distance of a line segment in a 2-Cartesian coordinate system using this specific aspect. So that is it for now, guys. Catch us in our next video, whereby we're going to look at the the concept of course, other areas of perhaps rays, angles, and planes in geometry. So that is it for now. Bye, God bless you. Catch us in our next video.